Hello, class. Welcome to class 3.1. In this class, we will be talking about mean, median, and mode, all measurements of a set of data. We'll be talking about simple interest, which involves using the percent, and charts and graphs. So let's get started with some class notes. First of all, I want to point out some advantages to this virtual class. Obviously, this isn't ideal. We would rather be doing this live, but there are some advantages. You get to replay videos and problem explanations if needed. Move at your own pace on the practice questions. And I will be doing more practice questions because I will be allowing you to pause and then continue. So I will be able to pack more practice questions into this lesson than I normally would. The weekend homework, as usual, set aside 45 to 60 minutes of quiet time. And a little preview of next week. We'll be talking about probability and working with negative numbers. All right, homework review. I'm estimating the average based on prior classes to be about 67%. Obviously, I'm recording this on Sunday, so there's no way I can know the actual average. All right, my tip of the day. It can be helpful to try to simplify some word problems into a simpler question or a picture. I'm going to use some examples in the homework review to show you how you might be able to use a picture to help you solve some of these problems. Here is our first homework question. At a fast food restaurant, a large serving of fries contains 560 calories. Of these calories, 240 come from fat. To the nearest tenth, a really important thing there, it's giving us some rounding information. What percent of total calories come from fat? All right, let's work through this. So if 240 come from fat, and there is a total of 560 calories in the fries, then that fraction would tell us the portion in terms of a fraction that comes from fat. So the first thing we would want to do is to turn that into a decimal. And the decimal that I get is 0.4287. And since we're rounding to the nearest tenth, we don't have to go any further than that. Let's multiply this by 100 because we can only do the rounding after turning it into a percent. And we get 42.857. We set up our door. Let's put the door right there after the 10th. And we look at the next number and it's a 5. So we're going to round that 8 up and our answer becomes 42.9%. There's our answer. So once again, if you want to review these explanations with this video class, you can pause and go back. There's the picture that I made to help understand what's going on in this problem as well. We're going to talk about pie charts later on in this lesson. So the total size of the pie is the total amount of calories in the fries. And the green portion of the pie is the amount from fat. So you might guess from there that the answer might be about 30 or 40%, about a third of maybe the whole pie or more. And sure enough, that's what our answer was, right in that ballpark. All right, next question. Find the percent of increase from 65 to 338. I drew a picture of this to try to diagram. So I started out drawing a little rectangle of the old amount, and I put the number 65 in it. The new amount is 338. We talked about the fact that percent of increase is always based on the old amount. the from number. So we identified the 65 as the old amount. We also talked about when we're doing a percent of increase question, we have to figure out the amount of change. The amount of change is going to be the difference between these two numbers. 338 minus 65 gives us 273 as an amount of change. So we set up our, I'm going to just review amount of change. This was the formula that we talked about. Over the old amount. This is going to be the basis of our percent. So 273 is the amount of change, and 65 is the old amount. Now, you might get a number here that just doesn't quite seem right. When we're dealing with percents, usually we're not talking about numbers more than one, but in this case, we are. And we still have to multiply that by 100 to turn it into a percent. That gives us 420%, which may seem like a strange answer to you, but when something goes up by this amount, by more than double, it's going to be more than 100%. So that's why that answer kind of makes sense, 420%. Next problem. A charity walkathon raised $1,200. This amount was 125% of the amount raised last year. How much was raised last year? So what we have to figure out in this case is the is and the of. Let's write that formula: is over of equals percent over 100. And we remember that we can also substitute for is and of the part and the whole. Sometimes that helps us figure out which is the is and which is the of. So the amount that was raised, this may not be obvious in this problem, is actually the is. So we're going to put that up here, 1,200. And then we also know the percent, 125. So we have 125 and 100 always goes there. That means we are missing the of. So we put our x there. And then we cross multiply. X times 125 is 125x. I always prefer to put the number first, is equal to 1,200 times 100. Now, I would recommend when you're doing that part of the cross multiplication, just put it in your calculator. 1,200 times 100 is 120,000. That way you're kind of done with that part of the calculation. Finally, we're going to divide both sides by 125. That cancels this out, and it leaves us with x is equal to 120,000 divided by 125, which should give you exactly $960. Now, one way that we could check this would be to divide 1,200 by 960 and see if it gives us 125%. And it will, but that is a good double check to do in a problem like this. Okay. Next question. This was my little picture. I forgot that I had a picture there. So our question was amount last year, 1,200 raised this year. A refrigerator normally costs $580, but Sam bought it on sale for 30% off. How much did Sam pay for the refrigerator? Let's look at my picture on this one. So in the blue rectangle, I'm showing the full price. In the tan rectangle, I'm showing a smaller amount because Sam is definitely going to pay less if he's paying 30% off. And I wrote the word guess in there because sometimes it's a good idea to just use your intuition and say, I'm not grabbing my calculator yet to figure out the exact amount. I just want to guess. So I would say if I'm paying 30% off, maybe $400 sounds right. But now let's do the work. I'll show you the reason why you might want to do that guess in a moment, but let's just do the work. Okay, in this case, we want to boil this problem down to, first of all, what is 30% of 580? And the meaning of that number is going to be the amount of the discount. That's how much the price is going to be reduced, 30% of 580. And we've talked about how of is a shortcut for multiplication, or a code word for multiplication. 30% we turn into a decimal, 0.30, and we multiply that by 580, and we get our discount amount. That discount amount, I hope you're working through these with me, $174. So this is because this is the discount and we've clearly labeled it as such. We know that since we're trying to find out how much Sam is going to pay for the refrigerator, we need to subtract this from the original amount. One more step to go. 580 minus 174 gives us $406. There it is. Now we come back here and we look at our guess and we say, well, that was pretty close. So what's the purpose of this guess? Well, it's to make sure that the answer that you end up with is reasonable. Let's say you had forgotten this last step. And instead of doing that, you said 174, and there it is in the answer list. But your guess was 400. Does it make sense that Sam would pay $174 for a refrigerator that was $580 and 30% off? No, that doesn't really make sense. So it helps you avoid the mistake of skipping that last step. Okay. I think we have one more problem here. This is an example. I've talked about how the GED people seem to like these questions where instead of giving the answer, you end up giving like what you would put in the calculator in order to find the answer. So it's important that we understand how to do these. This is a problem that is going to involve our is over of equals percent over 100 equation. So Jack earns a 5% commission on each sale. We know where to put the 5%. That goes up here. So now we're looking for the is or the of. If he is paid a $160 commission, now it's important that we understand that commissions are a smaller number than the amount of sales that went into calculating the commission. So the amount of commission is always going to be the is. It's the part, it's not the whole. That leaves us with X down here. And let's cross multiply. Just picking a different color here. We're going to cross multiply. We get 5X equals. And this time, because of the kind of answer that we want, I am not going to multiply those two. I'm simply going to show this as 160 times 100. Because we can see that those are the form of the answers here. We do not want to simplify that. The last step for these is always going to be familiar. We're going to divide by whatever X is being multiplied by. That is 5. And we are left with X is equal to 160 times 100 divided by 5. And do we have an answer that looks like that? We sure do. It's right here, B. 160 times 100 equals 5. Now, another thing I want to point out about problems like this is that it can be really helpful to do the math and see if what you get out of each of these answers sounds like a reasonable number. Now, let's keep in mind, Jack was paid $160 in commissions and was paid 5% on each sale. So he sold a lot more than $160. We know that. So these numbers that we get out that would be reasonable would have to be a lot more than $160. What do we get when we multiply 5 times 100 and divide by 160? I get 3.1. That answer doesn't make any sense. There's no way that Jack could have sold $3.1 and received $160 in commissions. Answer B, which is the one we determined to be the right answer, generates a number of 3,200. That sounds about right. Let's try C. 5 times 160 and then divide by 100. I get 8, and that means $8. That can't be right. A and C can definitely not be right. D, 5 times 100 times 1.60 gives us an answer of 800. Now that's larger than 160, but I want to point out that for a percent problem like this, that's asking for this format, you will never multiply three things together and get the answer. That's just not possible. So we might rule it out for that reason. But even if you didn't, you'd still be picking between B and D because A and C are clearly not right. All right, that was our last homework review. As I mentioned, we'll be talking about simple interest, central tendency, which is just a way of talking about getting averages and medians and modes for a set of data, and also talking about reading charts and graphs. So the pages that we are reviewing in the book today, 272 and 273, and 280 through 290. All right, here is our first video on simple interest.
Welcome to a video on simple interest. The goal of the video is to use the simple interest formula to answer a variety of interest questions. Now, even though most banks use something called compounded interest, the simple interest formula is a nice way to develop an understanding of how interest affects the earnings on an investment or savings account, or how interest will affect how you pay back a loan. Interest represents a change in money. So if you have a savings account or investment account, interest will increase your balance based upon the interest rate paid by the bank. And if you have a loan, the interest will increase the amount you owe based upon the interest rate charged by the bank. The simple interest formula is I equals P times R times T, where I is the interest, P is the principal or starting amount, R is the rate expressed as a decimal, and T is time expressed in years. Let's go and take a look at some examples. If you invest $3,500 in a savings account that pays 4% simple interest, how much interest will you earn after 3 years, and what will the new balance be? So for this situation, we're trying to find I, or the interest. P, the principal or starting amount, would be $3,500. R is the rate of return, so R is 4%, but it must be expressed as a decimal, so this would be 0.04. And then T is time in years, so T is equal to 3 years. We have all the information we need to determine the amount of interest that's earned in this account. The interest will equal $3,500, the principal, times the rate of return as a decimal, 0.04, times the time in years, which is equal to 3. So this product will give us our total interest over the 3 years. So we have 3,500 times 0.04 times 3. So the interest earned will be $420. But they also ask us what the new balance of the account will be. So we take our starting amount, 3,500, and so this interest represents the increase in the balance. So we add $420, and so the ending balance will be $3,920. So again, we found the interest earned, and then we also found the new balance of the savings account after 3 years.
All right, let's review that. Some important things to remember about this and put in your notes. First of all, you absolutely want this formula. I equals capital P times little r times T. And remember what each one stands for. That I is the interest, R is the rate as a decimal, P is the principal, which you can also think of as starting amount because principal is a strange word. And T is time in years. It's really important that it be in years. That's my first note here. If you're given time in months or days, it needs to be turned into years. And we'll talk about some common different kinds of times that you might see. The rate has to be a decimal. So you take the rate that's usually given to you, it's always given to you as a percent, and you're going to divide that by 100. And then the other thing to remember is that this formula only tells you the interest earned. Interest earned is an extra amount that gets tacked on the principal. So you take the original amount and you add the interest to get to the balance. So you have to be aware, are you being asked to find just the interest, or are you being asked to find the balance? There's some algebra needed when you're given the interest and you're trying to figure out what the principal, the rate, or time is, but we're not going to focus too much on that. So here's a practice question. Jenny puts $1,560 into a savings account. The account pays 2.5% simple interest. How much will she earn in 3 years? So think about that a little bit, start to work it out, pause the video if need be, and in a moment, I will continue to do that problem. All right, what I like to do in problems like this is identify these things that I know that I need. I need the principal. The principal in this case is the amount that Jenny put into the savings account, $1,560. The account pays simple interest of 2.5%. Well, that's R, but before we even write it down, we might as well divide that by 100 because we know that it needs to be a decimal. So 0.025 is going to be our rate. And we're talking about a time period of 3 years. And because they gave us years, we don't have to do any conversion of that. We are noting that it is exactly 3 years. We also want to pay attention to, are they asking for a balance, the total amount, or just the interest? And it looks like they're just asking for the interest. So our formula should work just fine. Interest equals principal times rate times time. Let me fill those in. Our principal is 1560. Our rate is 0.025. And our time is years. So let's multiply those. Even though I'm doing this video, I have not done these in advance, so I am calculating it along with you. And I get $117. That sounds like a reasonable number. And because we're only interested in the interest, not the balance, we can leave it at that, and that should be our answer. Okay, clear that off. One more example. Kelso invested $15,000 in an account that pays 6% interest. How much money will he have at the end of 12 years? Let's do the same thing. What is our principal? Principal equals the starting amount. It's either invested, put into a savings account, borrowed. In this case, it's $15,000. The rate, another way that you could do the rate is you could start with the percent and say equals 6% and then divide it. But you know that you always have to convert it to a decimal. 6 divided by 100 is 0.06 or 0.06. And the time, it's right here. It's in words, but it's 12 years. 12 years. And then we're ready to go. But we do want to pay attention to whether they're asking for the interest or the total amount. This may be a little bit harder to interpret, but how much money will he have means the total amount. Kelso expects his original $15,000 plus the interest. So let's do the calculation. The interest equals $15,000. I'm not writing the formula this time. 0.06 and 12 years. And calculating that, do it with me. And I get $10,800. Now that sounds like a lot of interest, but it's for 12 years. So it's a long period of time. So the longer you leave the money there, the more interest you get. But now, because we want the balance, we're going to call that the balance. We need the principal plus the interest. So 15,000 plus $10,800, which is $25,800. That's what Kelso would be expecting in this account at the end of 12 years. One more question. What interest rate will generate $400 in simple interest after 5 years if you invest $2,000? This is one of those questions I was hinting at before that's a little bit more complicated, but I thought it was worth including one, especially because in this video format, I have a little bit more time. So $400 in simple interest tells us that that's what I is. So we immediately see this is a little different because we know what the interest is. 5 years. We know that the time is 5 years. And we are investing $2,000. That's the starting amount. So that's the principal. Notice I'm entering these or writing these in different order, but the order really isn't important. It's important that I identify each one. But what don't we know here? We have interest, we have time, we have principal. We don't know the rate. So the rate is what we're trying to figure out this time. So let's put this together with our equation and see how this is going to work. our interest is $400. Interest equals PRT. Our principal is $2,000. I'm going to use parentheses this time. And our rate is what we don't know, so I'm just going to put an R there. And our time is 5 years, or 5. All right, so this is where we have to use some algebra in order to figure this out. What we need to do is get R all by itself. Now, we haven't really covered that in this class yet. It's going to come in a few weeks, but we can just do some basic algebra here. What we're going to do is to divide both sides by 5 first. The reason we're doing that is that's going to cancel this out, sort of like what we do with cross multiplying. 400 divided by 5 is 80, and that's going to equal 2,000 times R. Add some parentheses there. Once again, we need to get R all by itself, and what will help us do that is if we divide both sides by 2,000 now. That will cancel this out, and we will be left with R is equal to 80 divided by 2,000. Let's calculate that. 80 divided by 2,000 is 0.04. Now, when we find the rate this way, we have to remember that this is our rate as a decimal. And if we want to convert that into a percent, and we do, we have to multiply that by 100. So we're going to do the opposite of what we did in the other problems. Instead of dividing by 100, we're multiplying by 100 to get a percent, and we get our answer of 4%. What interest rate will generate $400 in simple interest after 5 years? If you invest $2,000, 4% interest. Don't worry too much about that one if that feels complicated, but I wanted you to at least see one like that. All right, next up, a little bit of statistics. Rob is going to talk about mean, median, and mode.
But that's where mean, median, and mode can really help us out. There are 3 different properties of data sets that can give us useful, easy to understand information about the data set so that we can see the big picture and understand what the data means about the world we live in. That sounds pretty useful, huh? So let's learn what each property really is and find out how to calculate them for any particular data set. Let's start with the mean. You may not have ever heard of something called the mean before, but I'll bet you've heard of the average. If so, then I've got good news. Mean means average. Mean and average are just 2 different terms for the exact same property of a data set. The mean, or average, is an extremely useful property. To understand what it is, let's look at a simple data set that contains 5 numbers. As a visual aid, let's also represent those numbers with stacks of blocks whose heights correspond to their values. 1, 8, 3, 2, 6. Right now, since each of the 5 numbers is different, the stacks of blocks are all different heights. But what if we rearrange the blocks with the goal of making the stacks the same height? In other words, if each stack could have the exact same amount, what would that amount be? Well, with a bit of trial and error, you'll see that we have enough blocks for each stack to have a total of 4. That means that the mean, or average, for our original data set would be 4. Some of the numbers are greater than 4, and some are less. But if the amounts could all be made the same, they would all become 4. So that's the concept of the mean. It's the value you'd get if you could smooth out or flatten all of the different data values into one consistent value. But is there a way that we could use math to calculate the mean of a data set? After all, it would be very inconvenient if we always had to use stacks of blocks to do it. There's got to be an easier way. Oh, man. To learn the mathematical procedure for calculating the mean, let's start with blocks again. But this time, instead of using trial and error, let's use a more systematic way to make the stacks all the same height. This way involves a clever combination of addition and division. We know that we want to end up with 5 stacks that all have the same number of blocks, right? So first, let's add up all of the numbers, which is like putting all of the blocks we have into one big stack. Adding up all of the numbers, or counting all the blocks, shows us that we have a total of 20. Next, we divide that number, or stack, into 5 equal parts. Since the stack has a total of 20 blocks, dividing it into 5 equal stacks means that we'll have 4 in each, since 20 divided by 5 equals 4. So that's the math procedure you use to find the mean of a data set. It's just 2 simple steps. First, you add up all the numbers in the set, and then you divide the total you get by how many numbers you added up. The answer you get is the mean of the data set. Let's use that procedure to find the mean age of the members of this fine-looking family here. If we add them all up using a calculator, or by hand if you'd like, the total of the ages is 222 years. But then, we need to divide that total by the number of ages we added, which is 6. 222 divided by 6 is 37. So that's the mean age of all the members in this family. All right, that's the mean. Now what about the median? The median is the middle of a data set. It's the number that splits the data set into 2 equally sized groups or halves. One half contains members that are greater than or equal to the median, and the other half contains members that are less than or equal to the median. Sometimes finding the median of a data set is easy, and sometimes it's hard. That's because finding the middle value of a data set requires that its members be in order from the least to the greatest, or vice versa. And if the data set has a lot of numbers, it might take a lot of work to put them in the right order, if they aren't already that way. So to make things easier, let's start with a really basic data set that isn't in order. It's pretty easy to see that we can put this data set in order from the least to the greatest value just by switching the 2 and the 1. There, now we have the data set 1, 2, 3, and finding the median or middle of this data set is easy. It's just 2, because the 2 is located exactly in the middle. That almost seems too easy, doesn't it? But don't worry, it gets harder. But before we try a harder problem, I want to point out that sometimes the mean and the median of a data set are the same number, and sometimes they're not. In the case of our simple data set, 1, 2, 3, the median is 2, and the mean is also 2, as you can see if we rearrange the amounts or follow the procedure we learned to calculate the mean. But what about the first data set that we found the mean of? We determined that the mean of this data set is 4, but what about the median? Well, the median is the middle, and since this data set is already in order from least to greatest, it's easy to see that the 3 is located in the middle since it splits the other members into 2 equal groups. So for this data set, the mean is 4, but the median is 3. So to find the median of a set of numbers, first you need to make sure that all the numbers are in order, and then you can identify the member that's exactly in the middle by making sure there's an equal number of members on either side of it. Okay, so far so good. But some of you may be wondering, what if a data set doesn't have an obvious middle member? All of the sets we've found the median of so far have an odd number of members. But what if a set has an even number of members, like the data set 1, 2, 3, 4? There isn't a member in the middle that splits the set into 2 equally sized groups. If that's the case, we can actually use what we learned about the mean to help us out. If the data set has an even number of members, then to find the median, we need to take the middle 2 numbers and calculate the mean or average of those 2. By doing that, we're basically figuring out what number would be exactly halfway between the 2 middle numbers, and that number will be our median. For example, in the set 1, 2, 3, 4, we need to take the middle 2 numbers, 2 and 3, and find the mean of those numbers. We can do that by adding 2 and 3 and then dividing by 2. 2 plus 3 equals 5, and 5 divided by 2 is 2.5. So the median of the data set is 2.5. Even though the number 2.5 isn't actually a member of the data set, it's the median because it represents the middle of the data set and it splits the members into 2 equally sized groups. Okay, so now you know the difference between mean and median, but what about the mode of a data set? What in the world does that mean? Well, mode is just a technical word for the value in a data set that occurs most often. In the data sets we've seen so far, there hasn't even been a mode because none of the data values were ever repeated. But what if you had this data set? This set has 6 members, but some of the values are repeated. If we rearrange them, you can see that there's 1 1, 2 2s, and 3 3s. The mode of this data set is the value that occurs most often or most frequently, so that would be 3 since there's 3 3s. Now don't get confused just because the number 3 was repeated 3 times. The mode is the number that's repeated most often, not how many times it was repeated. As I mentioned, if each member in a dataset occurs only once, it has no mode. But it's also possible for a dataset to have more than one mode. Here's an example of a dataset like that. In this set, the number 7 is repeated twice, but so is the number 15. That means they tie for the title of mode. This set has 2 modes, 7 and 15. Okay, so now that you know what the mean, median, and mode of a dataset are, let's put all that new information to use in one final real-world example. Suppose there's this guy who makes and sells custom electric guitars. Here's a table showing how many guitars he sold during each month of the year. Let's find the mean, median, and mode of this dataset. First, to find the mean, we need to add up the number of guitars sold in each month. You can do the addition by hand or you can use a calculator if you want to. Either way, be careful since that's a lot of numbers to add up and we don't want to make a mistake. The answer I get is 108. So that's the total he sold for the whole year. But to get the mean sold each month, we need to divide that total by the number of months, which is 12. 108 divided by 12 is 9. So the mean, or average, is 9. Next, to find the median of the dataset, we're going to have to rearrange the 12 data points in order from smallest to largest so we can figure out what the middle value is. There, that's better. Since there's an even number of members in this set, we can't just choose the middle number. So we're going to have to pick the middle 2 numbers and then find the mean of them. 9 and 10 are in the middle, since there's an equal number of data values on either side of them. So we need to take the mean of 9 and 10. That's easy. 9 plus 10 equals 19, and then 19 divided by 2 is 9.5. So the median number of guitars sold is 9.5. That means that in half of the months he sold more than 9.5, and in half of the months he sold less than 9.5. Last of all, let's identify the mode of this data set, if there is one. Well, let's see. There's 2 8s in the data set. Oh, but there's 3 10s. That looks like the most frequent number. So 10 is the mode of this data set. It's the result that occurred most often.
All right, I think Rob covered that extremely well, but just a few notes in review. We're talking about statistics of a list of numbers, some way to describe what is in those list of numbers. We have 3 different statistics that we're talking about here. The mean, which we can also think of as the average. It's just the total divided by the number of items in the list. The median is, as Rob pointed out, a little harder to find because we need the numbers to be in order. And when we put them in order, it's either the middle value, if there is one, or it's the average of the middle 2. Finally, mode, which is just the most common number in the list. There's one other, well, before we get to the other statistic, let's do a little bit of practice. We are looking at a list of 1, 2, 3, 4, 5, 6 numbers. Let's do the mean. So I'd like you to be thinking about this. I'm going to let you pause right now so you can try to work out these 3 numbers. And then I will continue and you can see how you did. So pause right now and work out the mean, median, and mode. Okay, let's work out the mean, median, and mode of these 6 numbers. So we have to add up these 6 numbers first. And I get 22. 2 plus 5 plus 1 plus 5 plus 3 plus 6. 22. And then we have to remember to divide 22 by the quantity of numbers, and there are 6. So 22 divided by 6 gives me 3.6 repeating, which I will round to 3.7. For the median, we need to find the middle, which means we need to organize this list in order. So I'm going to start out by listing 1 and kind of mark that off, and then 2 and mark that off, 3, 2 5s, and finally 6. It looks like I've got that in the right order. And When we have an even number of values, we will not have a middle. There's no middle here. So we need to take the average of the middle two. Here are the middle two. 3 and 5, the average of those is 4. 3 plus 5 divided by 2 is 4. So our median would be 4. And then our mode becomes kind of obvious when we organize them in order. We can see that we have 2 5s. So 5 is the mode, the value that is most common in our list. Okay. Another concept that's not covered in the video that you might be asked about is the range of a set of numbers. It's simply a measure of how spread out the numbers are. And the way we're going to find the range is to subtract the lowest value from the highest value. We find the minimum, we find the maximum, and we subtract. So let's do a little bit of practice. So we are identifying the minimum and the maximum in this list. We look across this list and the minimum seems to be 42. So I'm going to write minimum equals 42 and the maximum is 100. Those are the two numbers that we need to find the range. And then we subtract 100, the larger number, minus the smaller number, and we find that our range is equal to 58. I think I have another example here. The average high temperature is 80, and the average low temperature is 66. What is the range? It seems like a very different question, but the same thing applies. We simply take the largest value and subtract the smallest value. 80 minus 66 equals 14 degrees. The range of temperature is 14 degrees. All right, the last part of today's lesson is to talk about answering questions involving charts and graphs. So in this part of the lesson, I'm going to quickly go through some examples of different kinds of charts and graphs and questions that you might be asked about. And then in our practice session, we'll do that again in more detail. This is just going to be kind of an introduction to different kinds of charts and graphs. What we have here is something you might call a picture chart. So why do we call it a picture chart? It's because each picture of a car really means a certain number of cars. In this case, you can see over on the right-hand side, it means 50 cars. So if we were to talk about this last group here from 4:31 to 8 p.m., we would say there's 1, 2, 3, 4 cars, but that really means 4 times 50 equals 200 cars. We're really talking about 200 cars there. So we need to do a little bit of a conversion to work with a chart like this. Here's an example of a kind of question that you might be asked. How many more cars parked in the garage from 12:01 to 4:30, 12:01 to 4:30, than from 8 a.m. to noon? So we're talking about these two groups. We're not talking about this group at all. So we might say there's 1, 2, 3, 4, 5, 6, 7.5, 7.5 times 50 cars in this group, and 1, 2, 3, 4, 5, 5.5 times 50 cars in this group. And then we would do that math. So go ahead and work that out with me. 7.5 times 50 is 375 for that larger group. 375 here. And then for the smaller group, that would be 275. And we get a difference there 375 minus 275 of 100 cars. 100 cars, more cars parked in this time period than in this time period. Now, if you looked at this and you said, well, I don't know why you just did all that work, because I can see that there's two more cars here. There's half a car, there's a full car, and there's another half a car that's missing here. So there's two more cars here. 2 times 50 is 100. That's a quicker way to do that. You'd be absolutely right. There's nothing wrong with that math. But I just wanted to talk about both methods. All right, that's how you use a picture chart. Once again, I'm not going to spend too much time on these because we're going to do that in the practice session. Here we have a bar graph. What's the question that's being asked? How many complaints were there from 2007 to 2008? And it says about. Let's focus on that. So they're clearly asking us to estimate a little bit. And we're only talking about 2007 and 2008. So we're really focused in right here. And what they want us to do here is to add these two together. In order to add them together, we have to guess a little bit. How high is this bar? And we're looking over at this scale here. We look over here and we'd say, well, it seems to be about 27, I'd say. 27 complaints. And 2008 is a little bit easier to read. That looks like that's exactly 25. So we would add 25 and 27, and we'd get 52. But if the answers showed 51, that would probably be close enough. Even 50 might be close enough, depending on what the answers are. It's a little bit hard when you're reading bar charts to come up with exact answers. So a lot of times those will be estimates. Okay, let's move on to the next type of chart. Here we have a bar graph of another style. There's two things that are different than this about this one. First of all, it's horizontal. The bars are going the other way. But also we have two different color bars for each item. What we're looking at here is an analysis of 4 different movies. Profit analysis of 4 different movies. Movie A, B, C, and D. And we can see that the two colored bars, one is the cost of making the movie, and the other one is how much they made, how much income they received from the movie. And the reason that it's a profit analysis is the difference between these two is how much they made. So if I were to draw a little arrow here, we could say that this amount is how much they made. In order to calculate that, we would have to estimate the sales or the box office receipts, and we'd have to estimate the cost and then subtract the two. Let's look at the question that's being asked here. How much profit did film C make? All right, so we focus on film C. We're not interested in the other films. And it says profit equals box office receipts minus costs. Box office receipts look like they were 40. And let's note here, it's $40 million. But we're just going to use the number 40. That's our box office receipts. And we are going to subtract off the cost of making the movie. It looks like the cost of making the movie was $60 million. Well, this doesn't look good. They only had income of $40 million. They spent $60 million. If you do that subtraction, you are going to get negative $20 million, which means they lost money on this movie. They did not make any money. In fact, they lost a lot of money on this movie. All right, hopefully that makes sense in terms of how you would interpret that kind of a chart. This kind of a chart is called a dot plot. And a dot plot tracks something called frequency. And frequency sounds like a fancy word, but it just really means how many times something happened. The number of times something happened. So let's look at this dot plot and interpret it. We have all of these blue dots. Each blue dot represents something happening once. So I don't know how many blue dots we have here altogether, but let's say that there's 25. I'm just kind of guessing. This would mean that down here we have the minutes to eat breakfast. So that's what each of these mean. So this number of people spent 0 minutes eating breakfast, which probably means they didn't eat breakfast. So we would say 1, 2, 3, 4, 5, 6 people did not eat breakfast. 2 people spent 1 minute eating breakfast. 3 people, 2 minutes, etc. So once you understand that, it's a pretty simple chart. And we could ask a bunch of questions from this chart. Let's see what kind of question I had here. Oh, I didn't actually have a question for this one, but let me make one up. Let's say that I asked the question, how many people spent more than 7 minutes eating breakfast? We would look at this chart and we would say, well, all of these are more than 7 minutes eating breakfast. So I just have to count those dots. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17 people. It looks like 17 people took more than 7 minutes to eat breakfast. And we could ask all kinds of questions about this chart, but you just have to understand what the dots mean. That is called a dot plot. A line chart. So line charts are usually used to communicate how things change over time. So let's look at what we have here. Sure enough, down on this axis, we have time. These are months of the year, May through November. Over here, we have a scale that's showing us the number of ER visits. And it's the number of ER visits for scooter injuries at the Westside Hospital. There's a lot of information in the titles, in the labels, number of ER visits, months, and you want to pay attention to all of that so that you understand the chart. So each one of these dots tells us about how many ER visits there were. We might say that this looks like it was maybe 8. And this looks like, I don't know, 15, 30, etc. We could estimate each one of these. But we have to pay attention to what question's being asked. In this case, the question is, which month had the largest increase in number of visits? Now, that is a little bit of a tricky question to answer. And typically, when somebody sees a chart like this for the first time, they give the wrong answer. And you might be looking at this chart, and I would bet a lot of you are thinking that that answer is September. But that's incorrect, because September had the largest number of visits. That's true. If that was the question, which month had the largest number of visits, September would be the correct answer. But the one that had the largest increase in visits is actually August. And let me explain why. If we were to, again, estimate all of these, we could say that May went up to June, which was about 15. So that went up by 7. To July went to 30. So that was an increase of 15. It looks like in August, it went up to maybe 75. So that was an increase of 45, plus 45 between July and August. Then we go to September, and September looks like it was maybe 105. So you can see that it went up by 30 between August and September, but it didn't go up as much as it did between July and August. So there's a real simple way of identifying which went up or down the most. It's the steepest line. And you'll notice that this is the steepest line, and it's pointing to August. That's how you can find the largest increase. is look for the steepest line. All right, a pie chart. So this chart is talking about the sports camp weekly budget. And the budget for the whole camp is $2,250. And you can see here that the pie chart communicates what percent goes to different things, umpires and lunches and equipment, etc. The question is, how much does the camp spend on permits? So the way we would answer that question is to say, okay, they spend 8% on permits, and the total budget, 8% of their budget is on permits, and the total budget is $2,250. So this is an example of simplifying a problem down to a very simple phrase, 8% of $2,250. And we've learned that once we have a phrase like this, we change the percent into a decimal, and we multiply, and we leave this number alone. So do it with me. 0.08 times 2250 is $180 on permits. And we could find out the amount that was spent on all of these other things the same way. We want to find out the bus, 28%, 0.28 times 2250. These problems are not difficult, so you want to search them out and spend whatever time you need to get them correct. All right, at this point, take a short break and then resume, and we will get started with the practice. All right, let's get started on practice. These are actually some questions out of the book. We're just going to do one of these. We're going to do question 1. Lee borrows $1,500 for 2 years at 12% interest rate. Find the interest on the loan. I will just get you started here with the formula. And just to let you know, this formula is on the GED formula sheet, but you still have to know how to use it because it's not going to tell you what I and P and R and T stand for. All right, pause the video now, work on the problem, and then continue to see the solution. All right, so if we are filling in these values, the principal is the amount that she borrowed. That's $1,500. The rate is 12%, which we immediately convert to a decimal, 0.12. And the time is 2 years. Seems like we have everything we need, and we note that we are only finding the interest. So that makes this a little bit easier. We don't have to take that second step where we add it back to the principal. 1,500 times 0.12 times 2 years. And I get $360. And we are done because we just needed to calculate the interest. Okay, now I'm going to move over to my problems. Trish bought a computer for $1,100 to go to college. The loan is for 1 year, 6 months at a 6% simple interest. Which of the following expressions could be used to find the amount she will pay back at the end of the loan? So another problem that isn't asking you to find the actual answer, but just the math that you would do to find the answer. Go ahead and pause the video and then continue to see the solution. All right, here's our solution. Interest equals P times R times T. It looks like The principal is $1,100. That's how much she bought, or the loan was. And the rate is 6%. And the time is a little tricky this time. It's 1 year and 6 months. So we have to convert that into years. And that is 1.5 years, 1.5 years. So we're going to use 1.5 for that. And notice that all of these answers have 1.5 in it. So our interest part is going to be 1,100 times, I forgot to convert this to a decimal, 0.06 and 1.5. But the amount that she pays back at the end of the loan is going to include the principal too. So we have to add that back. Her balance is equal to the principal plus the interest. That will be $1,100 plus what we did up here. $1,100 times 0.06 times 1.5. So the answer that matches that is this one right here. 1,100 plus this math here, 1,100 times 0.06 times 1.5. Okay, next problem. Hannah loaned her friend $2,000 for 4 years to start a business. If the simple interest rate is 7%, how much interest will her friend pay over the 4 years? I'm just going to remind you here, we're just finding the interest this time. Go ahead and pause the video. All right, time to solve this one. So the principal is always going to be the big amount of money, $2,000 in this case. 4 years, there's our time. Doesn't matter which order we write these in. Simple interest, R equals 7%. And then let's convert it right away. 0.07, 7 divided by 100. How much interest? Okay, so let's, interest equals 2,000 times 0.07 times 4. Calculator, 2,000, 0.07 times 4. It looks like that is $560. You didn't get that correct. Hopefully that explanation makes sense. If not, rewind, review it again. Let's clear that off. Move on to the next problem. Sandra borrowed $1,200 to buy a car at 3% simple interest. If she plans to pay back the loan in 6 months, what is the total amount she will have to pay back in 6 months? Go ahead and pause the video and continue when you're ready. All right, let's solve this one. I'm going to do the same thing and start documenting what we know. She borrowed $1,200. That is the principal. The rate looks like it's 3%. Dividing that by 100, 0.03. A common mistake that you might make with the rent or the rate is to get 0.3, which would give you a very different answer. It's 0.03. And the time in this case is a little bit tricky. We have to figure out, well, okay, it has to be in years, and they gave us 6 months. 6 months is half a year or 0.5 years. So we want to use 0.5 there. And the total amount, that means we have to take the original 1,200 and add the interest. So let's first figure out the interest. Once you get used to these problems, they're not that bad. 1,200 times 0.03 times 0.5. I'm trying to point out the mistakes that you're most likely to make. It's either with the interest rate or converting the time usually. So what I get for this is $18. And that may sound like a small amount, but it's because it's such a short period of time. So she's going to pay $18 of interest, but we have to go back and add the original 1,200. Her balance is going to be principal plus interest equals 1,200 plus 18. $1,218. Okay, clearing that off. Next problem. Now we're moving on to mean, median, and mode. Once again, we have some questions from the book here. So I'm going to try to pick one that's, sometimes these problems are pretty tedious based on having too many numbers to work with. But I'd like to work with number 10, and we're going to find the mean and the median and the mode. So the average, the middle number, and the one that is the most often for 10. Go ahead, work on that, pause the video, and continue when you're ready. All right, let's work this one out. So we have 5 numbers here. Let's add those numbers up and find our mean. 36 plus 40 plus 38 plus 40 plus 40 again. I get 194 and I divide by 5. And I get 38.8 as the mean. 38.8. Now the median is a little bit of a pain because we have to organize these numbers. So let's do it. It looks like the smallest number is 36. The next number is 38. Cross these out as we go. And then 3 40s. That makes it kind of easy. 40, 40, 40. And we look for a middle number. And when we have an odd number, we will have a middle number, and it's right there. We can see there's 2 to the left, 2 to the right. Our median is 40. And finally, the one that occurs the most often, that's easy to find, right? We can see that there are 3 40s. So the mode is 40. That's it. All right. Let's go on to more of a question that you might find in an exam. What is the mean selling price for homes based on the chart below? So we're talking about the mean or the average selling price. Pause the video, continue when you're ready. All right, let's work this one out. So first of all, we want to be focused on only the selling price column. We don't want to grab the wrong column. So we are going to add up those, it looks like 6 numbers. It's always good to count how many values you're adding. Be careful. The most common problem you would make in an average is typing something in wrong. So I'm typing in these numbers, trying to be careful about it. I'm going to give you a little bit of advice on how to kind of tell if you might have made a mistake. So I know that I made a mistake here because I got a number that didn't make any sense. So I'm doing it again. I might have just hit like the division key instead of the addition key or something. A lot of things can go wrong when you're typing in this many numbers. So it pays to slow down and be careful. All right, now I get a total of 837,900. I'm going to divide that by 6. And I get 139,650. And the advice that I have is to make sure that it seems to be in the middle of the numbers that you have. So we have a smallest number of 119. We have a largest number of 175. And this number seems to be kind of in the middle of it, as are these other answers. But it just helps make sure that you didn't make a typing error in the calculator. So that's it for that question. Next question, involving the same chart. What is the median asking price? Now we're moving over to asking price, and we're finding the median. Pause the video, work on the problem, and then continue when ready. All right, as we talked about, unfortunately, when you're finding the median, you really have to get things in order. So I am going to try to put these in order. I found 124 seems to be the smallest number, and then 127 seems to be the next smallest. And I'm crossing these out because it helps keep track of it. 130. What's next? 145, it seems like. Then 155. And finally, 176. These problems are not difficult, but they're a little bit tedious. So we have an even number of values, 6. So you might remember that when that's the case, we will not have a middle. We'll have 2 middle numbers. So in order to find our median, we have to take the average of these two. 130,000 plus 145,000 equals, divided by 2. $137,500 would be our median. Next, what is the range of selling prices for homes based on the chart below? So now we're using that other type of statistic that we talked about, the range. And we're talking about selling prices. Go ahead and pause. Continue when ready. All right. So we are scrolling down this list and we're looking for the largest number. I think it makes sense to look for the largest first. We had previously talked about how 175 seemed to be the largest number. And now we're looking for the smallest number. That looks like it's 119,000. Once we have those two, we are well prepared to find the range. 175, 500, or subtracting 119,000, 56,500. That is the difference between the highest selling price and the lowest selling price. There we go. Next problem. All right, we're done with that chart. The attendance at the 4 performances of a play were those values. What expression could be used to find the mean attendance? Another problem that's just asking for the math that we would do, not the actual answer. Pause the video, work on your solution, and resume when ready. All right, continuing. So to find the average, we add up all the numbers. So we're going to add these 4 numbers, and then we're going to divide by 4 because there's 4 numbers. Which of these answers does that? This one's just adding them up. This one's only adding 2 numbers and dividing by 2. This one's adding 4 numbers and multiplying by 4. So these do not make any sense. And this one fits exactly what we need to do. Add the 4 numbers. That's what the parenthesis does, is say do that first. And then finally, when you're done, divide by 4. All right, here's the answer to the first question in the homework. It is just the word cow. I picked that because it was the name of our cat. Our son named our cat, a very strange name, Cow, which was quite embarrassing when we went to the vet. But that's what I decided to do for your secret answer to question number 1. Next question. The attendance at 5 college basketball games was these 4 numbers. What was the median attendance? Work on your solution, pause the video, continue when ready. All right. So for median, we have to put the values in order. Now, sometimes they're given to you in order, which is the case here. Look at this. We don't need to put those in order. They're already in order. We notice there's an even number of values and there is no middle. So we have to use these 2 numbers to find our median. We are going to add 366 and 420 and divide by 2. 366 plus 420 divided by 2. 393. And keep in mind that your answer better be in the middle of those 2 numbers, and it is. So that all looks good. C, 393. 10 students took a test, and the scores were as follows. What was the mode of the test scores? Work out your solution, continue the video, or pause the video, and then continue when ready. Okay, since we're trying to find the mode, we don't need to put these in order. We don't need to add them up, but we do need to carefully make sure we find the one that occurs the most. I like the technique of, first of all, scanning the numbers and saying, okay, there I see 2 72s. I'm going to use a different color here. I see some 75s. I see 2 75s. What else? Oh, there's another 75 right here. Do I see any more 89s? I do not. Any 90s? No. 85s? No. It looks like that's it. It looks like I have 3 75s and 2 72s. That makes 75 my mode. That's probably the easiest kind of question that you might encounter on a GED test. Just make sure you take enough time to not get it right and not make a simple mistake. Okay, for the last part of the practice, we are going to do a lot of work with charts and tables. So in this question, we are being asked, what is the highest sample length for batch 2? I want to point out something about this problem before sending you on your way. I got to put the answers up there. Notice over here, it's giving us color coding for batch 1 and batch 2. You are focused on just batch 2, the lighter bars. All right, work out your solution. Pause the video. Continue when ready. All right, continuing. So this is also a pretty straightforward problem. We're trying to ignore the dark blue bars because those are really not part of the question. We're just focused on the light blue ones. We're looking for the tallest one. There it is. And then we come over here and we try to estimate what that is. It looks like that is exactly 70. And that is our sample length in millimeters. Next problem. Which item decreased in sales the most from 2011 to 2012? This is a little bit tricky. You're going to have to absorb the information in these two charts. Go ahead, pause the video, work that out, and continue when ready. Okay, let's take a look here. So what I think you want to do in this problem is we're talking about decreasing from 2011 to 2012. So here we have our sales, 2011. Here we have our sales in 2012. We're looking for which one went down the most from here to here. We can see that apples went up. So it's not apples. Pears went down, looks like a little bit, 1,000. From 22,000 to 21,000. Bananas went up, so they didn't decrease. Cucumbers went up from 12 to 13. Tomatoes went down from 25,000 to 20,000. That's a lot. That's a lot more than the pears change, so we can rule out the pears now. And lettuce went down 2,000. But the tomatoes went down more. Tomatoes went down 5,000. So we are going to answer tomatoes, B. Those decreased the most between 2011 and 2012. Which product had the greatest increase in sales from January through June? Pause the video. Work out your answer and continue when ready. All right. So in this case, what you're looking for is sort of to just look at the beginning to the end. Let me pick a yellow color here. And I'm first going to talk about desktops. Desktops, I'm going to grab a straight line here. Actually, one with an arrow. Desktops went from here to here. They didn't increase at all, right? They went down a lot. Laptops went from here to here. They increased. Tablets went from here to here. They increased a lot. If you want to look at the numbers, they went from about 10 to about 95. Whereas laptops went from about 30 to maybe 55. So hopefully, like we talked about a few minutes ago, the one with the steepest line is going to be the largest increase. So the answer to this question was tablets had the largest increase. Clearing off my drawings, going to the next problem. Here we have a dot plot. How many people ordered more than 5 gallons of paint? Be careful here. Pause the video, work on your solution, resume when ready. All right. The key here is interpreting more than 5 gallons of paint. So 5 is not more than 5. So we're not going to include 5. We are going to include 6, 7, 8, 9, and 10. And we have 1, 2, 3 dots. It looks like 3 people or 3 orders were for more than 5 gallons of paint. Hopefully, that's clear that more than 5 does not include 5. It has to be more than. Here's our question. We have a pie chart. The pie chart's talking about cruise ticket sales by month and breaks it down by percent. So the question is, the combined ticket sales for the 3 largest months is about what percent? Pause the video, work on your solution, and resume when ready. All right, we want to do 2 things here. We want to visually find the 3 largest months. It seems pretty clear that January is one of them. It looks like December is one of them, and November is one of them. But I would also check the numbers. You can see 18%, 12%, and 13%. Do we have any other numbers that are that big? No, it doesn't look like it. The next biggest number would be 10. So it seems like we've found the 3 biggest ones. We just have to add those up. We can add percentages, 18 plus 12 plus 13. And that gives us a total of 43%. There is our answer, 43%. Oop, went too far. All right. Estimate the mean sample length for batch 1. So you might recognize this chart. We've already used it. Now we're talking about batch 1. And we are trying to estimate the mean. So this is a little bit of work because you're going to have to look at the chart and estimate a bunch of values and then find the mean. So go ahead, pause the video, work on your solution, continue when ready. All right, what I'm going to do here, grab my pen and go through batch 1 and try to estimate each one of these. It looks like this is 10. This is 40. This is 50. This is 20, 10 again, and 50 again. Now, one thing to pay attention to is that these are test numbers. There are not 7 tests here. There are only 6. 1, 2, 3, 4, 5, 6. So we have to make sure we're going to divide by the right number. But we are going to add up all of these numbers and divide by 6. So 10 plus 40 plus 50 plus 20 plus 10 plus 50 again, and then divide by 6, and I get 30. Now, one thing that I would always do after doing a problem like this is kind of draw a line through 30 and see if it makes sense. About half of the bars should be taller and half should be shorter. Notice shorter, shorter, shorter. We have 3, taller, 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 taller. It looks like our line, our average, is in about the middle of those bars. So that looks like a good answer. C, 30. Whoops, I don't have my right drawing tool. 30. Okay, next problem. What combined market share did the top 4 web browsers have? So we have this chart, this pie chart, browser market shares in January, a long time ago. So we are looking for the combined market share of the top 4 web browsers. Pause the video, work out your solution, and return to find the answer. All right, a little bit like the cruise question. We are going to find the top 4. That looks like it's definitely number 1 and number 2. And pie charts are often organized in order here, so we don't have to work too hard to find that order. It looks like these are the top 4, And we can see that the next browser, Safari, is less than Edge. So that looks good. 1, 2, 3, 4. We just have to add these up. 61.4 plus 11.8 plus 10.9 plus 4.7. We can add those all up at once. 61.4 plus 11.8 plus 10.9 plus 4.7. 88.8%. And there is our answer. Clear off the drawings. Here's our cruise ticket sales per month. Just an example how lots of different questions can be asked about the same chart. There are 30 million cruise passengers per year. About how many go on a cruise in December and January? So keep in mind that when you're given the amount, sort of like the budget for the camp, that represents the whole pie. All right, pause the video, work on your solution, and return when ready. All right, the first thing that we want to do here is to find the percent in December and January. So we have 18% in January, 12% in December. We add those two numbers. 18 plus 12 equals 30%. Now this becomes one of those examples of a pretty simple math statement. 30% of all of the people who go on cruises, which is 30 million. We're just going to use the number 30 because we're talking about millions. We remember to convert 30% to a decimal, of to multiplication. So it becomes 0.30 times 30, which equals 9. And we remember that that means 9 million people go on cruises in December and January. And there is our answer. Next problem. Here's that chart again. What was the approximate range in sample length for batch 1? Hopefully you remember what range is. Pause the video, work on your solution, and return to see the answer. Okay, so for range, we are looking for the highest and the lowest, and we are looking at batch 1. So we're ignoring all of the light bars. Let's not get confused by those. We focus in on the darker bars, and we look for the highest one. And it looks like there's 2 of them that are kind of the highest. Those would be at 50. And we look for the lowest, and it looks like there's 2 of them at 10. That's okay. It doesn't matter how many there are. We're just looking for the lowest. So we would say 50 minus 10 equals 40. The distance between the highest and the lowest for batch 1 appears to be 40. Hopefully you got that right. Next problem. Which salesperson had the highest sales per order? This one takes a little bit of work. So if it feels like it's a lot of work, then you're probably doing the right thing. Pause the video, work on your solution, return when ready. All right, so when approaching a problem like this, you don't want to do too much work. You don't necessarily want to calculate all of these, but you can. That might be the safest thing to do. But for me, I would gravitate toward the people with the most sales first. So it looks like Frank had a lot of sales. So let's find out what was his sales per order. What that means is to take his sales and divide by the number of orders. So 72,707 divided by 268 is $271. Let's look down the list. We notice that Janet had 87,000 in sales. Let's see what her sales per order is. 87,858 divided by 286. That's $307. So the only way that somebody would be able to beat these two would be if they had a really low number of orders, so that their sales per order. So let's just check Bill, just to make sure that we're on the right track here. What's Bill at? 41,107 divided by 217. He is at 189. And we'll just check the rest of them, just to show that it's not that much work to check all of them. And that may be what you want to do to make sure you get the right answer. Harry, 141,676 divided by 224. I get $186. Joe, 45,606 divided by 226 is $201. And finally, Martha, 49,017 divided by 228. She's at $214. So our instincts were right in that it looked like Janet was probably the winner, and we just confirmed it because she has the highest sales per order. Answer C. Now, another thing that I wasn't paying attention to, which might have helped me out, is if these are the only 4 answers, we didn't really need to think about Bill, or who else is missing here, Joe. We only needed to think about the 4 people who were possible answers. So that could have saved us some time. All right, next problem. Estimate the mean sales of mystery books over the 5 years. Notice that our chart has 5 different years here. This is a much busier chart, you might say, because we've got 1, 2, 3, 4, 5 bars for each year. And each bar represents the sales of a different type of book. So pause the video, work on your solution, and resume to see the answer. All right, first of all, we want to focus in on the right color bar. We're looking at the dark red bar. So then what I'm going to do is I am going to estimate the sales here. So notice these bars are almost the same color, but they're also in the same order. So blue, yellow, red, we're talking about the 3rd bar is the mystery books. So I'm going to say that this is 61,000. I'm going to say that this is 82,000. Now I'm just very quickly estimating these because the exact number is not really knowable or even important. We just have to get close. I'm going to say that's 55,000. I'm going to say this is 50,000. This is a great example of the need to estimate. This one also looks like it might be about 55,000. So those are the numbers I'm going to work with. And we're finding the mean, which says we have to add up these estimates and divide by 5 because there's 5 years. So let's see what we get here. 61,000 plus 82,000 plus 55,000 plus 50,000 plus 55,000. I get 303,000 as my total estimate, and I'm going to divide by 5. I get 60,600. Now, because of all of the guessing that we are doing here, we're expecting that there's just going to be an answer that's close to whatever we came up with, and we're just going to pick the closest one. And it's right here. I also want to remind you that you should also take a look at where that number fits relative to those bars. This is about 60,000. Now, what's a little bit different about this one is that we have one at 60,000, one that's way above it, and then three that are a little bit below it. So that looks okay. It looks like it's pretty well balanced, and that answer feels about right. But it's always worth checking where that line fits with the data. During which month were the sales of the three products the closest? I think that this is a pretty obvious solution. Pause the video and resume when ready to see the answer. Okay, so it's pretty much what the problem says. We're looking for during which of these months are these three dots the closest to each other? Well, January, they're not very close. February, it looks like they're getting closer to each other. March, they're pretty close. April, they're getting further away. May, even further away. And June, they're not even close. So it really leaves us with only this as the answer, C, March. Remembering that this over here, even though I probably should have had a scale on this, is indicating the sales of those three things. Which region showed a decrease in sales in the fourth quarter? This is a little bit tricky. Take a crack at it, pause the video, work on your solution, and return to see if you got the right answer. All right. So when we're talking about a decrease in sales in the fourth quarter, we sort of have to back up and consider the first or the quarter before it. So we're really looking at quarters 3 and 4. So for instance, let me draw some lines here. If we're thinking about the East region, which is the first bar, we would say in the third quarter it was here, and in the fourth quarter it was there. So that went up, right? So there was no decrease. I'm going to clear that drawing so that I can make another arrow. What about the next one? What about the West? It looks like the West went from here to here. Once again, an increase. That's not our answer. What about the North? The North went from here to here. Another increase. And finally, we look at the South, and the South indeed went down. So our answer to this question is the South showed a decrease in the fourth quarter. But the key takeaway here is, in order to know that, we needed to back up and consider where everybody was in the third quarter. Otherwise, we couldn't know whether it was a decrease in the fourth quarter. Estimate the mean sales of young adult book sales, blue, we're talking about the blue bars, over 5 years, without a calculator. So you're trying to visualize the average and pick from the answers here. Pause the video, work on your solution, return when ready. All right, so here's what I would do in this problem. I would draw a line where I think that average is. So I'm trying to split these blue bars. So this one's here, 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 here. I'm thinking like something like this sort of fits. That looks like I'm splitting the difference of those. maybe even a little bit higher than that now that I put it there. So I'm going to clear that off. I'm going to draw that line again. I'm going to make it up a little bit, maybe right here. Looks better. Yeah, I like that. Now I'm trying to guess, what is that number? Well, that looks like it'd be about 25. I come up here and I look at the answers, and there's 25. I feel pretty good about that. But I could also draw these other lines and say, what about 35? No, that feels too high. What about 15? Way too low. What about 10? Way, way too low. So by process of elimination, you could have also arrived at 25. So that's an example of trying to arrive at a mean without actually doing the calculation. Estimate the total sales in the West region. Good example of a chart problem that really requires some attention to detail. Go ahead, pause the video, work on your solution. And keep in mind that we're talking about estimating here. We talked about that a little bit before. You can do some rounding before you do the calculations. Pause the video, return when ready. All right. So first of all, we are going to identify the West region. This one's in the West region. This one's in the West region. This one's in the West region. We don't want to miss any. So West, just double checking. Any more Wests? No, I don't see any. So we're really talking about these three numbers. So let's do some rounding, like to the nearest 10,000. That sounds like some pretty severe rounding, but notice that these are rounded to the nearest 10,000. So that kind of makes sense to me. So I'm going to say this is 40,000, and this is 70,000, and this is 60,000. All right, now I could probably add those up without a calculator. 40 plus 60 is 100, plus 70 would be 170,000. But if you have to use a calculator, that's fine too. And we get this answer, a total of 170,000 in the West region. An example of using rounding to come up with an approximate answer. Estimate the range of total sales. Pause the video, work on your solution, and then return. Okay, when we're talking about range, we are looking for maximum minus minimum. So let's go down the list and very carefully find our maximum. I see $87,000 appears to be the largest amount here. So I'm going to write 87,858. I'm going to make a point here in a moment. Now I'm looking for the smallest. So far, 47,000 or 41,000 seems to be the smallest. 41,000, I don't see anything smaller than this number, 41,107. But I just noticed this talks about estimating. So let's estimate this number. Let's say this is 90,000 approximately. And this is 40,000 approximately. 90,000 minus 40,000 is $50,000. And there is our answer. Now, this answer, I believe, is the exact difference between the two, but it's not an estimate. That's an exact answer. So be a little bit careful about that. When it says estimate, look for rounded numbers to be the solution. Got a picture chart here. How many cars parked in the garage between 12:01 p.m. and 8 p.m.? Pause the video, return to see the solution. Okay, in this case, let's be careful about what we're looking at. 12:01 to 8 p.m. would include both of these groups. So we want to count all of the cars in both of these groups. I'm going to start with this one because I can see that there's 4. And then I'm just going to keep counting. 5, 6, 7, 8, 9, 10, 11, and a half. 11.5 cars, and I know that each one is worth 50 cars. So 11 and a half times 50. I'm just realizing that for the first time, I believe, I did not give you an opportunity to pause the video. I apologize for that. I was worried about that, but so 575 cars there. How many more complaints were there in 2010 than in 2009? All right, now your chance. Pause the video, come back for the solution. Okay, so we are focused on 2010 and 2009. None of these other years matter. And we are simply trying to figure out how many more in 2010 than 2009. So let's estimate. It looks like in 2009, there were 20. It looks like in 2010, maybe it's between 30 and 35. Let's call it 32. So we would say 32 minus 20. It looks like there were 12 more complaints. All right, that wraps up the practice session. Thank you for sticking through this all the way. If you did it, I know there were a lot more questions than we usually do, but I hope that that was helpful to you. And hopefully this whole virtual class worked out okay. So good luck on the homework, and remember to use the word cow for the first question in the homework assignment. All right. Have a good weekend, everybody. We'll see you on Tuesday.